Okay, we're going to be looking at these questions, which are all taken from the Specimen Pure paper from OCR. I'm going to give you exactly the length of time that would be allowed in the exam to do these questions. So in this case, it's 4 marks. I'm going to give you 4 minutes to do this question, and then we'll go through it. Right, so we've got 4 minutes to do that. If you can't do these questions in the time I'm allotting for these, then that means you need to do further revision on these topics. Go back to your textbooks, work through the chapters relevant in the textbooks, or you can go to the online videos on the topic and just make sure you improve it so you can do this question in where. And this question is a 4 marker and it's a straightforward question. You should actually be doing it 2 to 3 minutes if you're really up to speed, if you want to try and get A grade standard. Now with quadratic simultaneous equations, take the simpler one rearrange it to make it one of the variables the subject, and in this case we're going to use x, then we get rid of all the negative signs. So put 10 plus y everywhere x is, so we get 10 plus y all squared plus 8x plus, I made a mistake there, so I'll replace the x, change the size of my pen for this, so I want 8 times 10y plus y squared equals 4. So I'll get 100 plus 20y plus 2 plus y squared plus 80 plus 8y plus another y squared plus 4. And let's get group all the terms together. So we've got 2y squared, and we've got plus 28y. When we add up 20y and 8y, and then we're going to get another 96. 100 plus 80 minus 84 is 96. So divide throughout by 2, and then we can factorize. You don't have to factorize, you can just shove this straight into the calculator if you want. If you can't see the factors straight away, save yourself some time, shove it into your calculator. I would actually shove it into the calculator anyway, just to make sure you haven't made a mistake. So we factorize, we get y plus 6, y plus 8, and then we get y minus 6 or 8. Therefore, put that back into here, minus x will equal, put minus 6 into here, we get minus 4. Put minus 8 into this, we don't get minus 4, we get 4. And put 8 into this, we will get 2. And I think it's a good idea to actually pair up your terms to make it quite clear which one goes with which. Okay, so the next question's another 4-minute question. So let's
Hi, sir. Can you hear me?
Okay, so the time's up there. My students are in the class and will occasionally ask me questions. Try and answer them on the stream as well. Do you have a question?
Do you have a quick question?
Yep.
For question 1, is there more than one correct answer?
No, there is a question I could just ask: is there more than one correct answer to question 1? And no, this is the only correct answer to question 1, I'm afraid.
Okay, thank you.
So, question 2. This is another one you should be aiming to do in actually much less than the time. It's a standard question. You should know how to do this almost without thinking. You should just get straight into the question. So, you should be able to knock it off in 2 to 3 minutes, really. So, take logs of both sides. It doesn't matter what base. You might have saved yourself a little bit of time by doing base 4. I just did base 10. Because back in the day, we didn't have log base 4 on the calculators, so we just did everything base 10. So you do this with base 10, you can then bring the powers down. And bring the other power down using the logarithmic rules. Multiply out the left-hand side, we're going to get 2x log 3 plus log 3. Do log 3 times each term, and we still get 100 log 4 on the right-hand side. We're going to subtract the log 3, and I'm just going to take the x out of here. There's 2 log 3 for that bit going into there. I'm going to subtract this log 3 from both sides to get 100 log 4 minus log 3. You could work with your calculator. I tend to wait till the end, and I get 100 log 4 minus log 3 over 2 log 3. Now it wants the 3 significant figures. So type that into my calculator. I get 62. Get 62.59 and all the rest. So round that to 3 significant figures, I get 62.6. Any questions in the class? You can type this into your calculator and have numbers here. You can type this into your calculator and have numbers here. You can do log 4 both sides, which would have just given you 100 on this side. Okay, then log to base 4. This is just an old-fashioned way of doing it. If you do log to base 4, you just get 100 here, which is nicer, and you just get log to the base 4 of 3, which you can type into your calculator, and it will give you a number out as well. So that is also fine. Okay. Any more questions? Okay, we're going to go on to the next question. We're going to do the next question in 2 halves. I'm going to give you 3 minutes to go through it, and then another 3 minutes to go through the second half. So Time's up. Right, looking at this question. Generally, as a rule of thumb, when you're doing these proofs, you want to take the complicated side and try and turn it into the simple side. So what we're going to do is we're going to take the left-hand side, and I'm going to write this all in terms of sine and cos. So the top is equal to 2 sine theta over cos theta, and I'm going to divide that by the bottom, which, or actually what I'm going to do is I'm going to write times by the reciprocal bottom. Okay, so I'm going to times by 1 over 1 plus sine squared over cos squared theta. So I've written the tan squared as sine squared over cos squared, and doing times by 1 over that, which is the same as dividing by the bottom. So we're going to write this bit as a single fraction. Generally, getting things into single fractions is usually your path. So that's going to be cos squared theta plus sine squared theta over cos squared theta. And if you do 1 over that, then we're just going to flip this. So we get 2 sine theta over cos theta times by cos squared theta over cos squared plus sine squared is 1. So just replacing that cos squared plus sine squared with 1. And then what we can see is we can cancel out one of the cos's cos. So we get 2 sine theta cos theta. And that is just equal to sine 2 theta. We have a question. There's lots of easy ways to do. There's lots of ways to do these questions. There's just one question. Do sec instead of one plus sine squared over cos squared. Generally, the reason why I went this way. Why did I go with the sine? Because I had sine in the answer. So you could have just used a formula for sec here. I really don't think it's going to make a difference. It doesn't really matter how you do these questions. There's always more than one way to do it. If you found a nice way to do a question, then that is lovely. Generally, I do find if you're going from tans or secs or cosecs or cots into sines and coses, then actually flipping them into sines and coses early is usually the easiest way to do it. Not always. Okay, I'm quite happy to stand correct on that. From this one to this one, so all I've done is that 1 plus sine squared theta over cos, not like that. So I'm just getting asked, how did I get from here to here? So I've got that. Now what I'm doing is I'm turning this 1 into cos squared theta over cos squared theta, and then adding it to sine squared theta over cos squared. So I'm getting the same denominator. And now I can add these, and when I add these two, I get the same denominator on the bottom, and I just get the cos squared theta sine squared theta on top. Okay, that's how I get. Cool. Right, let's look at the second half of this question, which is going to use a bit of the first half, and I'm going to give you 3 minutes to go at this. Okay, again, this should be a standard question, especially as you got the answer to this bit from the previous one. So you just know from the previous question, half the question, that this is sine 2 theta is equal to 3 cos 2 theta. Divide both sides by cos theta, and you get sine 2 theta over cos 2 theta is equal to 3. So therefore, tan 2 theta equals 3. Put that into your calculator. So do inverse tan of 3, and it will give you something like 1.249 as an answer. Then if you just compare the two graph, you can use the unit circle to help you, and that's one way. I find that most students seem to find that looking at a graph is an easier way for them to work out the next value. So we've got our first value is between 0 and pi. So we've got 1.249. We know this is at pi, so this next one is going to be at pi plus 1.249. Now, the range is between 0 and pi, but when we divide this by 2, it's obviously going to come into, because we're going to divide by 2 in a minute, it will come into our range. So we've got pi plus 1.249 theta will equal that divided by 2, comes out to be 0.625, 3 significant figures, and the other one will come out to be 220 to 3SF when you've divided that by 2, that by 2. So just, and we don't, you can, it doesn't matter if you go and find an extra one. When you divide by 2 and you find it's bigger than pi, then you can just cross it out. You can also use this method to find the other ones. If you use that method, feel free to do that. You can see you'll get your first angle here, and then your next angle will be, that's pi plus the angle there. Tells you how to find it there. And then you can just keep rotating around through by pi each time. Any questions in the class? Okay, I think first part's a 3-minute, so let's get on with that. Should be hopefully much easier to do 3 minutes. Okay, the key to this question is the language in the question. It says verify the coordinates of Q are 1, root 3. So we don't actually have to prove it, and we don't have to solve the simultaneous equations to do it. We just have to make sure that they do actually go both curve and both the circle go through Q at 1, root 3. Now the circle, we know center naught radius 2, so therefore the circle will have equation x squared plus y squared is equal to 4. So if I decided to use the y is equal to root 3, then we get x squared plus 3 4, so x squared 1, so x equals plus 4 minus 1. So therefore it goes through 1 root 3. That is okay for the circle. And we just need to now show that it also goes through the parabola. So when x, so if we do y equals 1 over root 3, 4 minus x squared, and then look at when x is equal to 1, simpler, this will tell us that y equals 1 over root 3 times 4 minus 1, which equals 3 over root 3, which equals root 3. Therefore, we have verified. Okay, but it goes through, and Q is at 1 root. Because we got 1 root 3 from our parabola, and we got 1 root 3 from the circle. No need to solve the simultaneous equation to show it, because it just says the words verify. Right, the second part of this question is a bit more interesting and shows why you need to have more time to do the questions. So let's see how you get on with this one. Right. Now, the question I've got for all of you is, did you spot that you could use geometry to make this a little bit easier? So if you draw a little dotted line down here and a little dotted line here, you've got basically a circle. And if you draw that line down here, you've got a triangle. So we can start off by finding the area underneath the parabola, which will be quite straightforward. Let's just do that. We're just going to find the area underneath the parabola. So we're going to go from 1 to -1, which will give us the whole of this area here. If I shade it in yellow, if I integrate the parabola, okay, I'll get this area, and then I need to take away whatever the area of the circle is underneath that, and the triangle. We'll look at that in a second. But let's do the parabola first. So we do the parabola first. We integrate from -1 to 1 of 1 over root 3, 4 minus x squared dx. Now, what actually I did, I'm just going to just look back at my answer. Actually, what I did is actually I didn't integrate from -1 to 1. I actually integrated from 0 to -1, then times the answer by 2. So it doesn't really make a difference. Let's go through that. I'm going to do it the way I've just started doing here. And I'm going to integrate 4x to get 4x. I'm going to get the x squared will go to minus x cubed 3 and 1. Now, naught would have been easier actually than double it, because basically you get naught and naught, and you just got to put the 1 in to get your answer out. To put the 1 in, I'm going to get 1 over root 3 times 4 minus 1/3. I'm just going to take the 1/3 outside because it's going to be a factor of both. And then I'm going to get minus 1 in here. I'm going to get -4. And I'm going to get plus 1/3. So effectively, I get this value doubled. So 4 minus 1/3 times by 2 times by 1 over root 3. You put that all into the calculator if you want, or you can do it ahead, and you get 2 root 3 over 9. That gives me the yellow area. That's the answer to the yellow shaded area. Now, what I'm going to do now is work out this angle here, because I know that that distance there is 1, and I know this distance here is root 3. So therefore, tan of theta will equal opposite over adjacent, 1 over root 3. So theta must equal 30 degrees. So therefore, this whole sector here, 2 theta, will equal 60 degrees. So the area of that sector will equal 60 over 360 times by pi r squared. So it'd be times by pi times 2 squared. And that just comes out to be 2 pi, 2/3 pi. Works out. You get 1/6 of 4 pi, which is 2/3 pi. Now, I've only worked out the sector bit, so I want to work out these two triangles next. So I can work out the two triangles. And I know that they've got a height of root 3 and a base of 1, and I've got 2 of those. So therefore, that area will be equal to 2 times a half times the base, 1 times root 3. So it's just equal to root 3. So therefore, my shaded area is equal to 22 root 3 over 9 minus root 3 minus 2/3 pi. So let's just simplify this bit. That's going to be the equivalent of 9 root 3 over 9. Take that away from 22, gives me 13 root 3 over 9 minus 2/3 pi. Now you could have worked out the circle by integration. I'll just go through that because we can do it by, the best method is probably by integration by substitution. So if we wanted to work out, if we rewrite the y squared plus x squared equals 4 as y is equal to the square root of 4 minus x squared, okay, and we integrate between -1, 1 dx, then we're going to let x equal 2 sine theta as our substitution. And when we do our substitution, we differentiate that. And this is definitely the harder way of doing this. And we get 2 cos theta. So integrate, I'm going to go from -1. If I've got x equals -1, then theta will equal minus pi by 6 when I put it into here. And when x equals 1, theta will equal pi by 6. So if you make x equal to 1, divide by 2 is a half, inverse sine of a half gives me pi by 6. And similarly for minus 1, you'll get minus pi by 6. So we're going to integrate from minus pi by 6 pi by 6. And we substitute in our x, we get root 4 minus 4 sine squared theta. So the dx will be equal to 2 cos theta d theta. And now I've changed all my variables. So I'm just going to make it something simpler. And that's just the same as 4 cos squared. So square root that will give me 2 cos theta times by 2 cos theta. Actually ends up giving me 4 cos squared theta. Simplify all that. This is just the same as 4 open brackets cos squared theta, because you've got 4 times 1 minus sine squared. 1 minus sine squared is cos squared. This is 4 cos squared. Square root that's 2 cos theta times by 2 cos theta gives me 4 cos squared theta d theta for that bit. And then what we're going to do is we're going to use a trig formula to make this simpler to integrate. So we're going to use the fact that 2 cos squared theta will equal cos 2 theta minus 1. I got that from the 2 cos 2 theta equals 2 cos squared theta minus 1. And just rearranged it. And I just realised I made a slight error there. Plus 1 there. So I'm going to integrate from minus pi by 6 to pi by 6. I'm going to change this to, well, 2 cos squared equals that, then this will just equal double of this. So that's 2 cos 2 theta plus 2 d theta. Integrate that. 2 cos 2 theta will come from sine 2 theta. The 2 will come from 2 theta. And then we're just going to put our limits in. So what have we got here? Put our limits in, put pi by 6 into here, get pi by 3. Sine of pi by 3 is root 3 over 2. Pi by 6 times by 2 is pi by 3. Put the same values into here and we get minus root 3 over 2 minus pi by 3 when I put the minus pi by 6 in. Because I'm taking away, everything effectively gets double, and I get root 3 plus 2 pi by 3, just like I did earlier. So it's up to you to choose which way you'd prefer doing. Okay, you might have preferred the integration by substitution, or you might have preferred the geometry. So do remember, you can take shortcuts with geometry. Any questions in class? 4 minus x squared half. If you were to differentiate 4 minus x squared to the half, the reason why you can't do it like that. So we've just got, if we had reverse chain rule of 4 minus x squared. So if you got that and you reverse chain rule, you're probably thinking it comes from this. No problem is when you differentiate this, you're going to get a 2x coming out times by the 3 over 2. And we don't have that x out. No, because then you've got a product and then it's all going to be messy. It just doesn't work. So the student just, as I said, can I just divide by the x and just divide by 1 over 3x? As soon as you divide, if you put 1 over 3x here, you've now got a product and you've got to use parts or something, unless this differentiates exactly to this, which it doesn't. So reverse chain rule doesn't quite work in this situation. Did you get the same answer? Okay. Right, that's all for today. Okay, I hope you enjoyed that. Hopefully that'll inform your revision going forwards.